Okay, good. Oh, and now I made that mistake, so C4H6. Now what?
The 1 over initial.
Oh yeah, we can find the 1 over initial pretty easily. Good. So what number did you plug in there?
1 over 0.01.
So yeah, the initial concentration was 0.01. So we can find that y-intercept by plugging 1 over 0.01. So what did that come out to be?
100.
Right. Okay, good. And then what?
Oh, that's the y-intercept?
Yeah, do you see why? Because we're figuring out this term, and that's the b term, and y equals mx plus b. So that's something we want to figure out. What did you do next?
I was gonna look for my.
For the slope. Good. Now the slope is the change in y over the change in x. So what calculation should we do on the numerator? Do you propose?
The furthest apart.
Yeah, let's do the furthest apart to get the most data. Mhm.
Well,
So what calculation are we going to do?
Should we use the 6,200 and the 1,000?
Oh, well, let's use the first row and the last row. We'll see if that works out fine. So the first row, so what calculation are we going to do if we use the first row and the last row for the numerator?
1 over 6,200 minus 1 over.
Ah, now, in the numerator, we're working with the vertical variable. And what is our vertical variable here?
Not time.
Yeah, not time.
right.
What's the vertical variable?
It's the concentration.
Yeah.
Oh, it's the,
1 over.
wait, it's 1 over concentration.
Which we can see from our equation, right? The equation here, this thing on the left must be the vertical variable.
Right.
Okay, so so what calculations do we need to do in our numerator?
So,
1 over 0.0028.
That's right.
Minus.
1 over that.
Right.
Oh, and underneath.
And how about for the change in the horizontal variable?
Okay, that's this one,
What's our horizontal variable?
but that's the time.
Just the time, not 1 over the time. Notice that this is not 1 over t, it's just t. So the equation itself reminds us what the vertical and the horizontal variables are, but you can also look that up in our table, right? The table said that for second order, it's 1 over a versus t as the variables. Okay, so what calculation do I put down here in the bottom?
Just
6,200, so.
Yeah, 6,200 minus 0, which is 6,200. By the way, notice that here, you put the lowest number first in the subtraction, so you have to put the lowest number for the time first. You could have done 1 over 0.01 minus 1 over 0.00208, but then in the bottom you'd have to do 0 minus 6,200. You have to do the subtractions in the same direction, if that makes sense. Well, I think it was more intuitive here to do final minus initial. So here we did final minus initial on the top and final minus initial on the bottom. We can do this in one step if we put it in parentheses.
Shit, 373 point something.
Okay, what did you get there?
I got 373. Did I do that wrong?
480.7.
You all got different things.
Oh, oops. Oh, well, I know what I did wrong. I punched in the wrong.
Oh no,
place.
you got what I got. Good.
Oh, the change.
Okay, that was, I actually, I put a 6 instead of the.
Okay.
Okay, so, but it is 0.01. And then,
Yeah, that won't work. You need parentheses to tell it where the numerator starts and where the numerator ends. And you don't need the parentheses around the fractions.
I don't?
No, but you can leave those if you want, but you still need one parenthesis to tell it where the numerator started and another parenthesis to tell it where the numerator
Oh,
ended.
no wonder. Okay, so so I should put the whole thing in.
The whole numerator. Anytime there's more than one thing in a numerator, you have to tell the calculator where the numerator starts and where the numerator ends. But notice that these little fractions only have one thing on top and one thing on the bottom. So the little fractions don't need parentheses. It's only this big fraction that needs parentheses because this is the thing with more than one thing on the top.
So in this case, would the
Is
K
that-
Good.
be molarity over seconds?
Oh, that's good. Let me catch up to you, but that's a good thing to think about. So we got here that the slope was 0.0614. So this gives us 1 over C4 H6 equals 0.0614 time. All right, what did you think the units were?
Molarity over seconds, because you have the molarity and the.
Well, here's how we can work that out. These two terms have to have the same units. What's the units for this term?
1 over molarity.
Yeah, maybe it's better not to use molarity though. Molarity,
1 over moles over liter?
yeah, what is 1 over moles over liters? That's like a complicated fraction.
Liters over moles.
Yeah, that's right. That's the reciprocal of that, right? So wouldn't it be best to write this as liters over moles instead of 1 over moles over liters? That's kind of more complicated.
Oh, because we wanted to do it because we wanted them to match the natural logarithm units in the last one. That's why we did the
Yeah,
canceling out.
here there's no natural logs, so this really does have units.
Okay.
In the previous example, we had natural logs which don't have any units, but this term does have units, so we have to plug in what its units are.
Wait, so the 1 is now liters? I'm confused. Why is it liters over mole?
Well, would you say that these are the units?
Yeah.
But would you say that that's the same as this?
Oh. Okay.
1 over moles over liters is the same as liters over moles, right? When you divide something into 1, that means you're taking the reciprocal,
Okay,
and that means flipping the numerator and the denominator. That's important, so does that make sense?
yeah.
So we're not putting in units for the number 1, we're putting in units for this concentration, and these are what the units
Yeah, I
turn
mean, I
out to
knew
be.
you flipped it, but I was
Right.
just trying to figure out why.
Because it's the reciprocal.
Okay.
All right, this means the reciprocal of this concentration, so we should use the reciprocal of its units.
Okay.
So the K's units are liters over moles.
Let's see, so now this here, the units for time will be seconds, right?
Right. Oh, liters,
And here's K.
so liters over moles times seconds.
That's right. You could have done the same thing using this term. You could have said these have to have the same units because they're being added. Well, again, the units for this would be liters over moles. Maybe that would have been more obvious because they're on the same side of the equation. In order to add these, they both have to have the same units. Okay. So now we have that K is liters over moles over seconds plus 100.